Okay, good morning, everyone. Just wanted to have a quick lecture today, 30, but there's a free slot available here. So we are going to study, solve the examples on DH problem, that is Diffie-Hellman, that we have seen. So if you remember, I just revisit Diffie-Hellman problem. So we have two users, Alice and Bob. They should have these each other, like one is the private and other one is the public set of these. Then you do is there are two public parameters, p and alpha. P is a prime number and alpha is the primitive root of that prime number. And what you do is you do a public key. I'm sorry. Alpha raised to private key mod p, right? That you send. This is capital A. That you send across, okay? And what the other user does is it raised to alpha raised to the private key mod p, right? So this is a public key that you calculate, and then when you receive the public key and private key here, you do the case calculate the cases by raising it to your own private key or public key. Can someone please help me if I am correct? And this other user also does the same thing. Cases the Bob has received Alice's public key. It raises to its own private key and take the mod operation. Okay, and at the end, these two session keys has to be same. Okay, so this is a Diffie-Hellman algorithm that we have seen. Okay, I hope this is correct. Now, the terms which are used here, P, A, small a, capital A, these terms can be referred from different books as different variables. Let me just give you an idea. So in the presentation that is available for all the panels, instead of P, they are referring it as Q, the prime number. Okay. So, and instead of small a, they are saying it as capital XA. Okay. So, and these are the terms that we have seen, conditions that we have seen last time. And this is for user A and the user B. Okay. And then you calculate the session key at the end. Okay. So X and Y, X is the private key and Y is the public key that the term is referred like this. There are a few more terms I'll show you. Okay. So let me give you this as an example. So Alice and Bob agrees on the prime number P as 23 and base G. Now G is treated as alpha. Okay, the public, these are the two public parameters, 23 and 5. Okay, so what you have to do here is you have to choose a private key, that is small a. Okay, so choosing a private key, you can choose any number. Okay, remember that number has to be less than p. So 6 is less than 23, so you can consider any private number, private key. So what Alice does is, Alice has to calculate a public key like this. So in our case, we will do the alpha raised to a mod p. Okay, what they have done is here g raised to a mod p. Okay, so alpha is replaced by g here. So these are the I'm giving you some terminologies which are used at many places. But the meaning is, or the calculation is same. So g is 5, your private key is 6, and you're taking mod 23. Okay, so this is what the calculations, and Alice calculates a public key as 8. Okay, so Alice has calculated private key as 6 and public key as 8. Okay, similarly, Bob does the same thing. Bob chooses, you have to choose the private key and calculate the public key. So public key chosen by Bob is 15. Okay, so and you have to calculate the public key using g raised to b, that is b is the private key mod p. So this calculation gives you the public key as 19. Okay, so public key is 19 here. Okay, and you are sharing this public key with the other user. Okay, so 8 is uh, sent over here and 19 is sent over here. So, right, so when you and Alice receives the public key of Bob, what you have to do is you have to calculate the session key. Okay, so KSS is replaced by S here. What you have to do is received public key raised to private key. Okay, mod P. So do the same thing. You will get the session key as 2. Okay, and Bob computes the session key as received public key from Alice. Alice's public key is 8. 8 raised to its own private key, that is b. B is 15. Okay, so when you do the calculation, you get the same key as session key, that is 2. Okay, so this is how a Diffie-Hellman generates a common session key or a private key automatically without sending this session key over the internet. Okay, what you are sending a public key with the other user on the internet. So sharing a public key will not be a problem, and this will generate your own private key. Okay, so we'll go for the next example. Yeah, can you please solve this example? So the prime number q is 353 and the alpha is 3. Okay, so instead of p you have q here. So let us choose a small a, that is private key. You can choose any number. I request you to choose your own small a. Okay, Is anyone got the solution?
Yes, sir.
Yeah. So what is the small a that you have chosen?
I chose 7.
Okay. So what is the
So
capital A?
capital A, 69.
Okay. And this one?
Then private key for Bob is 5. So
Okay.
small b is 5. And capital B is 243.
So it is calculated. 243 is calculated.
Yes, sir.
Right. And session key?
I'm getting 250, 250. Both cases.
In both cases, you are getting 250. Okay. Is there any other combination that other student have calculated? There must be many combinations possible. One of the combination is choosing private key as 97 and public key will be 233. Not sorry. These are the private keys of both the users. So XA and XB. So these are the private keys. So you have to calculate the public keys YA and YB. And the session key in their case is 160. So I need a few more combinations. Remember, you'll get at least one question on this basis, on this Diffie Hellman, and practicing all these problems will definitely help you calculating the quick answers. What is 3 raised to 7 that you have got?
So I calculated it directly.
Okay.
So it's 2187 mod 353.
Mm-hmm. And no one else is calculating.
I'm doing it, just getting some calculation mistakes, so I have to check once.
Okay.
So if I'm assuming like a small a as 8, then I'm getting capital A as 207. I'm not sure whether that's right or wrong.
Can someone please check? So 8 and 207.
7.
2187 into 3 divided by 353. What is the small b
Sir,
that?
even I'm getting 8 and 207.
Okay. Srija, what is the small b that you have chosen?
6. And I'm getting 23.
323.
No, so, with small b, I took 6, and capital B, I'm getting as 23.
Sorry, it got stuck. Okay.
It's 23 euro 22.
Hmm. Okay. And what is the session key that you're getting?
Yes, I'm just checking that once.
Hello, sir.
Yeah.
Sir, I try with the Alice private key as a 2 and Bob as a 3, and I get the same session key.
Session key. So what is the
Yes.
public key you have calculated for Alice?
9
2 and 9. And for Bob?
and 3 and 27.
Okay. And what is the session key you
I
are
try
getting?
with the 10 and 12. First, I try with the 10 and 12, but the calculation like
Was too
bada
much.
ho raha tha wo.
Okay.
Yes.
Okay.
So I take one number.
No problem. So what is the session key you're getting in this case?
23. 23.
23. Okay. So for 8 and 6. What is the session key you are getting, Srija?
Sir, for I'm getting 331.
331. So the basically what how do you check whether it is correct is you for both the calculations you don't just calculate one value. When you do the calculation for both the session keys for Alice and Bob, they should match with each other. That's it. So once they match, you're good to go. Let me go to the next. Yeah, try to see whether this one is okay. So user A and B use the Diffie-Hellman key exchange technique with common prime, that is 71, and primitive root as 7. So the problem goes like if user A has private key as 5, what is the public key? If user B has chosen private key as 12, what is the public key? So just check if this is correct. You also calculate the part C, that is shared key. Yeah, so what's the session key you have got?
30.
Anyone else? Okay, so I hope you'll get the answer as 30. Uh, so I have a question for you now. We have seen uh, two key establishment methods. One is the key transport, and one is the key agreement. So Diffie-Hellman falls in which category? So the key transport where I'm sharing my key with you. Okay, so that is a key transport. Key agreement, both the parties decides the private key.
Sir, Diffie-Hellman would be key agreement because Alice and Bob have their own private keys.
Correct. So Diffie-Hellman goes under this category. Now, if suppose I want to use a key transport, that means I have a key private, okay, which has to be used at both the ends for encryption or decryption. So let's say this is Alice and this is Bob. Can I make this process secure? How do I send this private key over the internet? Is there any better method? Can I use RSA here?
So
No.
we can send like the encrypted format from one end to other, and the other person can decrypt it or something like that.
Yeah. So do you want to encrypt the private key itself?
Yes, sir. And then you can decrypt using your public key.
Decryption doesn't happen using public key. Decryption has to happen using private key.
Okay, sir.
Yeah. So if you are using, let's say, RSA, okay, A wants to send this KPR, okay, what A has to do?
So you're in RS, if you're using RS, then the key size will be given, and then you encrypt it according to the key size.
Okay, so let's say K public is a 512 bits of B. So there will be pair of keys. One is the private key and the other one is public key. So using RSA, okay, you have to encrypt the KPR and send it across. Okay, so that the key transport will be secure, because anyway RSA again is a very secure method. Let's say we are using AES for encryption, actual encryption, okay, because this is a symmetric key encryption. KPR is used at both the ends for encryption and decryption, and we know that AES is so secure, it is not uh, attacked by anyone yet. And a public key cryptography is also RSA is also a secure thing, okay, but AES is more secure than RSA, okay, because in RSA there is a public key, okay, but in AES there is no public key. Only the thing is the private key has to be shared using some secure channel. So here we have to combine both the things to secure key transport. Okay, so that is one thing that you should understand. And there are a few more just terminologies that I want to. So the types of keys: public key, private key, permanent key, session key, one-time key. These are the types of keys that you look at. Then what are the issues that we are talking about in key management? That is key generation, how the key generation takes place, how do we distribute the keys. So key generation comes under key establishment, okay, and there are many ways for key generation. Distribution comes under how do you distribute the keys. We have seen that couple of lectures back, how many keys you can generate and all these things. Where do you store the keys? Whether do you store it centrally or distributed manner and all these things. There has to be a key renewal process, revoking process, verification. Key verification is again just like a digital signature. There has to be a key expiry. You have to keep those records, okay. And then whether someone is misusing the keys, because next time, maybe tomorrow, we'll see this problem which is called as man in the middle attack. Okay, I'll explain you the scenario. I'll explain you how the key is taken over by man in the middle, right? So whether someone is misusing the key, that you have to keep a check on, okay. And these are some of the problems explained in detail. So what I suggest is, instead of discussing these theoretical concepts, you should read it by yourself. So this is a symmetric key distribution, just like what we have discussed, symmetric key distribution. Okay, you can use public key infrastructure, PKI, for distributing symmetric key or private key, right? So I guess that should be it for today. You have to maintain these terms. Just do a self study for these terms. Okay. These are few more terms which you have to keep in mind. So actual data encryption happens with the private key. In case of symmetric key, you are using, if you are using DES or AES, you are using one key, that is data encryption key. Then you maintain the session keys wherever one person logs into the other machine, and you have the master keys, which is a new concept, but it is not. It doesn't have any cryptographic protection. It is, it is just like a combination of keys. You might have heard about the concept of a locker, bank lockers, where you also have the key and the bank also has the key. So whenever the two keys comes in together, then you can open the locker. Otherwise, only one key doesn't open the locker. So this also we have discussed, if you remember, 11 scientists coming in together, and there was a condition, only 6 scientists, if there are only 6 scientists available, then you can open the locker, so something like that. So these are the key hierarchies. We have already seen this KDC scenario. I've explained you this part, and tomorrow I'll explain you the attack, man in the middle attack, that is called as MINT. Okay. So let me stop sharing.